So here we are, review of 5.2, division algorithm. I'm gonna just do one example of the long division algorithm really quick. And then we're gonna do an example of the synthetic division again, really quick, and then we're gonna jump into 5.3, just so you kind of have remember how to do it. And like I said the other day, I misspoke. Remember, you do have to fill in every time, okay? Anytime you're missing anything, like if you're missing an x squared somewhere, you gotta put it in as a 0. Okay, you need that 0 placeholder. Okay. Reason I didn't do it, and I did change it in the notes. Sometimes when they're at the very end, I'll be honest, sometimes I forget to put them there. And then guess what? It still works out. Because when 0 goes away, it just goes to a constant, and usually the constant goes away, so it works out. And so Hawks will kind of fool you and go like, oh, you did right. Problem being is, if there's a missing and it's a higher degree later somewhere forward, it is going to mess you up, because then everything kind of just reduced down by 1 from there. So let's look at this in 5.2 real quick. By the way, I think, no, it's in 5.3. I did it. Never mind. In 5.3, at the very bottom of your notes, I'm not even going to do it in your, and I'm saying this now, so 1, it'll be on video. 2, you'll hopefully remember it. Hawks is super nice, guys. Okay. But your textbook can be a little bit meaner. And you probably don't care because you're not having to do anything in your textbook. But if you want to guarantee success, sometimes it's good to go into the e-textbook, find one of the harder problems. Okay. Which is what I did on 5.3 to go to the very bottom. I actually pull one of the questions from your textbook and work it out. Okay, and when I download the notes, you'll see it. Okay, so you can actually see how this thing works when you do have something really ugly. Because I want you to realize that now, once we get done 5.3, there's nothing not factorable for you anymore. Now, it doesn't mean it's easy. Okay, it means it's going to be monotonous. It's going to be tedious. I'm going to make it look real easy today. Okay, because if not, we wouldn't get through one example. Okay, you're going to think, wow, that's easy. No, it's not. Okay, because it's a lot of checking, and there's no way, there's no trick anyway to tell what I'm about to show you in 5.3. Okay, so before we get there, let's look at the tools again. Okay, so we got it. We got this polynomial division algorithm. Remember, this is the one that looks like whenever we did the long division. Okay, so let's just kind of come down here. You can kind of read these theorems if you want. It's good to try to start dissecting theorems, try to understand them. Don't freak out on them too much, okay? Because examples are going to help out a lot more, okay? So like I said, let's just do one. We've already done this one, but let's do it again. You probably already have it in your notes. Here's how to do it, okay? But let me just do it by example. So on this one right here, we have polynomial long division. This is polynomial long division. Remember that Hawks will tell you, okay, in 5.2, it'll tell you do this using long division. Or it'll say do this using the synthetic division I'm going to show you, okay? Moving forward, you'll just kind of have to decide when's the best to use with either, okay? So notice to write this as long division, we would take this. Let me get my pen. And we've got 2x plus 2, and we're going to divide that by 6x cubed minus 2x squared plus 4x plus 12. Okay, now remember, I looked through here. I've got a 3, I got a 2, I got a 1, and then I got a none. You have to have it that way, okay? If anywhere you're missing an x in that as it descends, just put a 0 in it. Put plus 0 and walk on. Okay. Good. Okay. So doing this kind of like I said, once again, review. First thing you gotta do is you gotta look at this front guy, and I'm gonna take him off here to the side. I'm gonna go 6x cubed. I'm gonna divide it by that 2x. 6 divided by 2 is 3, and that's going to leave me with x squared. The moment I do that, I'm going to write that right here, 3x squared. Now I'm gonna take that 3x squared and I'm gonna distribute it back to that 2x and that 2. Okay? So notice whenever I do that, I get 6x cubed, and then I get what? 6x squared. Now, if we were being literal right now, we can all agree that that 6x cubed is positive, and so is this. If it helps, I want you to realize what you're doing is this. You're subtracting that whole thing. Okay? Now, what do you have to do with that multiplication symbol? That subtraction symbol? Distribute it in there, and it flips the sign on everything. Okay? So notice this guy right here is going to go to subtract negative. That's going to go to a negative. That will remove that. Okay? Then we come in here. Negative 2 minus 6 is going to give me 8x squared. Bring that guy down. Plus 4x. And then we start the whole process over again. Okay? That's right. That's going to be negative. So I've got this negative 8x squared. I'm dividing it by 2x. I'm going to get negative 4x. Write down my negative 4x, and then you're going to do the exact same thing again. That's why they call it an algorithm. You keep doing it till you're done. It's the same process over and over and over again. Negative and positive, make a negative. That's going to give me negative 8x squared minus 8x. Doing that, that's going to turn everything in here positive, correct? That goes away there. That's going to turn into 12x. Bring down the 12. And you do one more round. Okay? So we've got this 12x divided by 2x. That's just going to give us a 6. So put plus 6 there. Do your multiplication. 12x plus 12. I think you can all see, once I do this, all of that goes away. Okay. And so you're left with a remainder of 0. So your answer for this one, when it was all said and done, is going to be, well, I'm just going to circle instead of rewriting, is going to be that guy right there. Okay. Because there's no remainder. Okay. What that also means is this. You could take this 3x squared minus 4x plus 6, multiply it to 2x plus 2, and you would get back to that. Remember, you could check it just like you could long division back in the day. Okay. Those are the easy ones to check. The harder ones to check whenever there's a remainder. I'll be honest, I've never decided to check those. I'm just always like, well, hope I get the green bar. And remember that now, is it good? Remember, if you have a remainder right here, okay, you would just write that, you'd add that. If there was a plus, if it was a positive, you write plus the remainder on top, and then don't forget the divisor there. Okay, just as the remainder. Okay. We're going to do more of long division later on. Right now, I want to push this next one to you, and we're really going to be using a lot of synthetic division. Okay. Let me scroll down here so you can see one. There's another one if you want to try it, or you can look in your notes. Do look in your notes to see how to do the complex ones. Synthetic division, there is how you would do it, but why don't we just do it by example instead? Okay. So we come down here, start looking at example. Now I want you to realize something. Look at this very carefully. So when I write this, you can see what it's going to see. When you go back up to your definitions, when it starts talking about the remainder theorem and stuff like that, you're going to see something called x minus c. Okay. X minus c is basically how you're seeing it is this. And I want to kind of describe it, not describe it, you know what it is. It's literally when you factor something, remember how you get like, say, x plus 1, x plus 1. Okay, you know, or x plus 1, x plus 2, whatever. That would be your x minus c, except just somewhere in there, there was a negative. Because think about it, when you make x equal, or x equal to 0, you end up getting x is equal to -3, right? Plug it back in, it gets positive, whatever. That's all it's saying. It's saying, hey, when you factor something, something is a factor of this whole polynomial. And so what we're going to see here is this guy is a factor of this whole polynomial. Think of it this way. If I said 5 divided by, or sorry, 105 divided by 5, we can all agree I'm going to get a remainder of 0. If I divide this by this, I'm going to get a remainder of 0 because that guy's a factor of that, okay? In this lesson, you're always going to be having a factor. Here in the next lesson in 5.3, we're going to be looking for those. We're trying to find zeros. Where does this work? When does it not? Okay. So real quickly, let's do 1, 3, 2. Trying to see if there's one on here that had none. Let's do this one. Oh, this one does. Yeah, this one actually works. Look at this one very carefully. And here's how you do it. It's a step-by-step process, so be very careful how you do this. Notice this has an x minus 3. Okay? If you made it equal to 0, what's it going to be? X is equal to what? That's what you're putting in first. Okay? So notice you're going to put a 3 right here. Now, I write mine like that. Some people, okay, I'm going to come over here. Some places do it like this. Okay, I don't. I do it the other way. Doesn't matter, it's the same thing. Now you're going to write all your coefficients. Okay, these guys right here. Starting with your leading one, working your way down. So I have a 2. I have a negative 12. I have a 25. I have a 13. And then what do I have? After the 13, what should I put down? Exactly, I got a 0. Because there's no x value, x to the power of 1. There isn't one, so I got to put a 0 there. It's like a placeholder, okay? And then I put down my constant, okay? Or sorry, there isn't x. Sorry, I put down a 0. There is an x right there. I'm mixing that up. Sorry, I apologize. What do I got to put down for the constant? Sorry. Because notice there is an x there, but where's there not anything? The constant, right? There isn't a constant there. So go ahead and put it in. So I've got this negative 13. I got the negative 24. Put your 0 in for that constant. This is the one I didn't put that in originally. Reason being is, guess what? Didn't really matter. It gave me the right answer no matter what. Okay? But had there been like, say, look at that, see that negative 13x squared? If there hadn't been an x squared there, and I just decided to keep doing the math, it wouldn't have worked. Okay, does that kind of make a little bit more sense now? So, Hawks gifted. Out of all the examples, I picked the one that, oh, if I mess it up, it wouldn't matter. Okay, so that's what I kind of want you to kind of be aware of things. Are you good so far? Okay, so first off, you look at your x minus 3. Make it simple for yourself. If it's x minus 3, put a positive 3. If it's x plus 3, put a negative 3 there. Then write all your coefficients in order, making sure to put a 0 in for a placeholder if you're missing anything, even the constant. Okay? And then you guys start bringing numbers down. And you get a freebie right off the bat. Come down. I'm going to draw myself a line here. Like I said, you get a freebie right off the bat. Bring down the 2. You have to bring down the 2. You multiply diagonal, you add vertical. Okay? So notice what I'm going to do now. 3 times 2 is 6. Then you add the verticals. Negative 12 plus 6 is going to give me a negative 6. And then you multiply the diagonal again. Negative 6 times 3 is going to give me negative 18. 25 minus 18 is going to give me 7. 7 times 3 is going to give me 21. That's going to give me what? 8, exactly. Oop, I didn't put the negative in. 8 times 3? 44. And then notice that gives me a 0. But then 0 times 0 gives me 0 and 0 added to 0 is 0. You see how mine worked out? No matter what, it still worked out on this one. Okay. That's why it worked out. But still, don't skip steps. And that's how come I was just like, oh, no, you're good. And then I was literally driving home going, wait a minute, you moron. No, it doesn't work out because my mind literally went through one and it was like, no, that's not going to work out. If you're missing like a x squared, you're going to get a 0 somewhere that you shouldn't get one. And then may zero things out after that. Okay. What you're looking for when you do this correctly. So here's how you know if you did it right in 5-2. Okay. You got a 0 right here. Okay. You have to get a 0 right here. This is division. It's called synthetic division. But this says that x minus 3 is a factor of this 2x to the 5th, so on and so forth, okay? And that's what we want, okay? Now, what you just did was you dropped that 2x to the 5th, you dropped this 5th degree polynomial, you dropped it by 1 power. Literally, just 1. So you could rewrite it right now, okay? Now, mind you, we're actually factoring. X minus 3 is a factor, right? So I could write x minus 3. And you don't need to right now. I want you to kind of have that in your head for whenever I start showing you 5-3 here in just a second. Okay? So notice this 2 here now becomes 2x to the 4th. Negative 6x cubed. Plus 7x squared. Plus 8x. And then guess what? I don't have what? I don't have a constant. For this lesson, that's all you got to do for 5-2. That's all you're doing. You're getting it to go down by 1. Now, guess what I could do if I wanted to? If I wanted to, if I could find another factor in here, I could do this again and take it down another power. And then do it again and take it down another power. Okay? Are you good with that? Do you understand what I mean whenever I say this guy's a factor of this guy up here? Okay. I hope so. We good with 5-2? How are you with the synthetic division? Are you okay with it? It's pretty straightforward, right? Multiply on the diagonals, add on the verticals. Okay? So let's jump into 5-3. I said a lot. I have a whole bunch of other questions in here that you can go back and look at. Okay. Just go back in. I've downloaded notes, I believe, onto this one. Okay. I'll add this section of video to last week's what do you call it? Videos. Or I may just come in and just refilm a 5-2 for y'all. All right. Don't worry too much about the definitions here. Let me read them to you. I'll explain them briefly, and then we're going to just jump into the math, okay? The rational zero theorem states if f of x is some polynomial. Remember when I showed you how you could just plug it in, you can make an x squared out of that, whatever. Is a polynomial with integer coefficients. That means you don't have like complex numbers, okay? Integer coefficients, and a can't be 0. Then any rational 0 of f must be of the form p over q, where p is a factor of the constant term a0 and q is a factor of the leading coefficient n. And I misspoke. You can have on this one just integer coefficients. It has nothing to do with complex. Caution. Before applying the rational zero theorem, we need to know 2 things it doesn't do. The rational theorem doesn't necessarily find even a single 0 of a polynomial. Instead, it identifies a list of rational numbers that could potentially be zeros. The theorem says nothing about irrational or complex zeros. Okay. What this is doing. Now let me bring it down. Right? Every single one of you in here at this point in time has factored everything, okay? You factored polynomials of the quadratic formula, you factor them into like x plus 1, x minus 2, whatever. You've even done it with cubics. You could even do it with a power of 4. It's a little tougher. Probably haven't done that too much, but you could do it with terms of 4, right? Because then you could just group them, right? But what do you do when they get higher? It's a little tougher then. Like if I give you 5 terms, or 6 terms, or 7 terms. That's when things start getting a little bit like, uh-oh, now what do I do? What we're going to start doing, what the rational theorem says is, hey, how about we start listing some numbers? Now, what does it mean? Now, this is review. What does it mean by creating a 0 or a 0 of a polynomial? What is that?
X-intercept?
Yeah, exactly. It's the x-intercept, right? If I plug in this number that I solved for and I plug it back into my polynomial, what should it equal at the end? 0, right? When you get something like, and you factor something x minus 3, x plus 2. Well, x minus 3, x plus 2 would give me what? X is equal to 3 and negative 2. Well, at 3 and at negative 2, that's where that parabola would have been going across the x-axis, right? And so therefore, you would have had zeros at that point. We're looking for those. We're trying to find those zeros because we're not giving them anymore. And we can't factor them. The things are too large now. We can't do that. So we have to start trying to find factors. You're basically looking for numbers that you can plug into that thing and get a 0. Okay? And it gives you a formula to use. It's kind of a formula. It's a tedious formula. Okay? Because the way I'm going to show you today, here you go. Dude, that's easy. No, it's not. It's easy, but it's long. Okay? So just kind of be ready for it. Okay? But you know what a 0 is. I need you to know what that 0 is. Okay? So let's do an example here. Notice it says, and I pulled these from Haas. Instead of using an example from the book, I pulled these from your homework question. Look carefully. Use the rational 0 theorem to list all the potential rational zeros. Okay, here's how this is done. Hear me out. It gave you a formula of P over Q. Okay? Let me show you again, in case it blew right by you. Notice what it says right here. Where A of 0 is Q. Okay? Right there. Sorry, where P is A of 0 and Q is a factor of the leading coefficient. Okay? All this means is this. Okay? So look carefully. When I look down here at this x cubed plus 4x squared plus 16x plus 64, I'm looking at this going, okay, well, this right here is my P. This right here is my Q. Because I'm trying to make a rational number. I'm looking for all the factors. Okay, now hear me out. This is where it can get a little bit weird. This is how I write it. Okay? First off, P. You're going to want to be as ordered as possible on this, okay? You need to start listing all the factors of 64 that you can think of. Okay? So let's think about it. My rocket's kind of weird. I've got 1 and 64, right? Well, then think about what don't I have 2 and what?
32.
32, exactly. What else could you have?
16.
Exactly. 4 and 16. What else? Got one more.
8.
8. Yeah, it's 8 times 8, right? And you're done. That's all your factors. Okay? What is my leading coefficient? Now I'm going to write down my Q. What is my leading coefficient?
1.
1. So how many factors?
1.
1, exactly. Okay. You're in luck. It's a 1 on the bottom. Okay. So okay, now hear me out. For 1, let's just go ahead and finish this part of the problem. Every single one of these, I don't know how Hawks is going to want you to put this in. I'll be honest, okay? I think you could probably put it all into a parenthesis or like a set notation, which is what I'm going to do. Every single one of these has a plus or minus in front of it because you could have a positive or a negative on every single one of those. But here it is. Okay, are you with me? First off, there's a 1 right here. Realize this is what you're seeing. P over Q. So notice I do 1 divided by 1. Well, that's just 1. 2 divided by 1 is just 2. And so on and so forth, right? That makes sense? Okay. So I can come in here and write all these right here. And we're done. That's pretty sweet, isn't it? But what would have happened if I had another number on the bottom? Now I got to go back through there and divide every single number by that next number, making sure there is no other sort of duplicates. Okay, like let's pretend, just real quickly, pretend, don't write this down. I'm going to write it in orange so you know something. What if there had been a 2 here as well? Well, then I would go back through the list and go, okay, now I've got 1/2. I got to add that to the list. Well, 2 divided by 2 is what? There's already a 1. I don't rewrite it. That's what I mean by duplicates, okay? So does that kind of help out with that one? Okay. So yeah, you're going to get fractions. This list can get really long. This list right here doesn't look long right now, does it? Well, but here's the problem. You've got how many? 1, 2, 3, 4, 5, 6, 7. Each one of those has a plus and minus. There's actually 14 numbers there. Okay. Are you good? Okay, now that's how you do step 1. What you just found all the possible zeros for that polynomial. But you don't know which one it is. Which means you gotta start testing. You gotta start going, which one's it gonna be? I don't know. You gotta start plugging in numbers into your calculator, which literally means taking that 1 and plugging it into that formula and going, which one of these, whenever I plug it into my calculator, will give me a 0 at the back end. And then when you try out 1, then what do you gotta try out? If it doesn't work, what do you gotta try out? -1. Because there's a plus and minus there. Okay, so let me show you how this works. Use polynomial division. I'm going to help you out real quick and let you know that guess what? The number you're going to be looking for? 4. Okay. How do I know it works? Watch this. I'm going to take now. I have the benefit of having like that all-seeing eye that can look over things and just go, I'm not going to sit here doing notes for you and spend 8 hours. I'm going to have little tricks, you know, like a computer program. They'll tell me, this is it. I'm like, sweet, thank you. Okay, so I picked it out for you. You're not going to have that on your final. You will probably have that at home. Okay, but you won't have it on your final. Okay. So look how this is going to work. We start going through, we start testing things, right? Okay. Well, look here. When I finally get to 4, now hear me out. To have 4 here, what did it have to look like to get a 4 there? Remember, think of the last time. When we started doing synthetic division in in 5-2, what did it have to look like?
X minus 1.
X minus 4, exactly. Because when I solve it, I get a x equals what?
4.
4, exactly. Okay, so think of it that way. So to get this, I had over here an x minus 4. Well, okay, doesn't that mean that x minus 4 now, I'm going to show you why this works, okay? I'm giving it to you. I'm going to tell you right now, it works. But how do you know it works? Well, first off, you know it works because you already tested it in. I want you to go in there real quickly and put 4 in to this whole equation. Put it in. Put in your calculator, put 4 cubed minus 6 times 4 squared plus 16 times 4 minus 64. You should get a 0 out the back end of that thing. That's all you're doing in step 1 is you're literally taking your calculator and doing this. Nope. And then nope. And you just keep testing numbers until you get that 0 in your calculator. And when you find one, you go, sweet, I got a 4. That means this thing used to look like x minus 4. If you tested negative 4, that means it used to look like what? X plus 4, right? Because x plus 4 equals 0, solve it, you get x minus 4. Did you get a 0? Very good. Okay. Now, here's what you're trying to do. I'm going to be honest with you. Right now, you could go ahead and factor that guy. Right now, just the way he is, you could factor him. Couldn't you? I mean, really look at it carefully. Just bear with me real fast here. You could come in here and go, hey, I've got x cubed minus 4x squared plus 16x minus 64. Well, can I not just come in here and just group those? That's a grouping problem, right? Go back to 13.5 in intermediate algebra. It says, hey, anytime you have 4 terms, see if you can't do what? Just group them. Well, let's factor that really quick. And notice on this first term here, I'm going to get x squared. And that's going to leave me with x minus 4. Oh, well, look, what's x minus 4? Doesn't that seem familiar from somewhere? How'd I find that? Wasn't that one of my factors that I tested? Notice this next one, I'm going to pull out a what? 16, and then I'm going to get what here? X minus 4 again, and then I get x squared plus 16 x minus 4. Now that's factored in. Now you could solve it, right? You get x equals 4, but then you get what on the other end? You get 2 complex numbers. X is equal to negative 4i, x is equal to positive 4i, and then you get x equal to 4. Are you good with that? But that's easy. But let me show you how this will work actually in another way. Do synthetic division. I've got a 1. I've got a negative 4. I've got a 16, and I got a negative 64. You got a freebie, right? That's your 1. 1 times 4 is 4. And then what am I left with? 0. Hey, 0 times 4 is what? 0, right? Bring down the 16. 16 times 4 is what? How do I know it worked? Because of the 0 there. Well, doesn't that 1, that just means what? I bring down the power from a cube to a what? A square, exactly. Notice I have a 0 there. That means I don't have an x value there, right? That means that's gone. And so then I just have a what? A 16 here. And then nothing else. So what does that look like? And that guy is factored at this point. Now, use polynomial division and the quadratic form if necessary. Identify the actual zeros. You have not identified the actual zeros yet. Okay, you just factored. So what you got to do is you got to come in here. I know, looking at the division algorithm, another one of my factors is x minus 4. You understand that, right? Does that make sense to y'all why x minus 4 is one of them? Because when I plugged in that 4, it made a 0. I was looking for the other zeros. I only found one. But by doing the algorithm, I could go in here and try to find this. Now, hear me out. This is one of the nice ones. Because guess what? That's factorable for you right now. You can do this. You have all the skills necessary to factor a quadratic. I hope so. Because now we're going to make this whole thing equal to 0, and we're going to get x is equal to 4. We know that. If I look at x squared plus 16, make it equal to 0. Notice I get x squared is equal to negative 16. Square root of both sides. What do I do when I do a square root? You got a plus or minus. And so I get x is also equal to, hey, you got to pull out that negative, don't you? And that becomes I. Put my plus or minus there. What's the square root of 16? There's all your zeros right there. One of them was a real number, but two of them were what? Imaginary. They were complex numbers. Notice what the thing, didn't it caution us about that? It said, hey, you made this whole list here to identify all these possible zeros. It doesn't mean all of them are going to be real. It means you might have some that are going to be complex. Now, let me warn you now, and we don't really hit on it until chapter 15:4. I'm going to say right now, complex numbers always come in pairs. It should be kind of obvious why. Because to get it, you're having to take a square root of a negative number, and when you take the square root, you're always having to do it what? Plus or minus. And so they come in what we call conjugate pairs. Okay? Are you good with this? Now let me help you out a little bit. Now these next two parts I'm going to show you. These are just, one of them is really good. The other one, if you got a really big list, it works. You're not going to have one like that in this class. But the other one does work if you have like, man, wow, look, I've got 85 terms to look through. Okay, and if you have a really mean calculus 2 professor who wants you to do it by hand, then there's ways. Can you realize that we've got a really big list here, right? And this is actually a very small list, comparatively speaking. Well, we can use some special tools to kind of help us a little bit, okay? We can say, hey, excuse me, is there any way to like narrow this list down to like try to whittle it a little bit instead of having to just look at every number? Well, yeah, we got some tools, or at least it'll help me say, hey, how many positive numbers am I looking for? How many negatives am I looking for? Okay, well, let's look at the first one, and it's super simple. This first one is called Descartes' rule of signs. And to be honest with you, I'm going to tell you right now, that right there is just a whole bunch of like, I mean, I understand it, but hear me out. You're literally just looking for a change in signs, okay? But it doesn't really help you reading it, so let me just show you by example, okay? So they give me a quadratic right here, or sorry, a cubic. You got to write it twice, but let me just go with the first one. This is the original. You're looking for sign changes. That's it. Okay? So look. Between the leading coefficient and the next number, is there a sign change? Yeah, the front number, the leading coefficient, is it positive or negative? Okay, the next number, is it positive or negative?
Positive.
Was there a sign change? No, they were both positive, so no sign change. But notice what happens between the next two numbers. What happens? Right here, there's a sign change. And so I put a 1 there. But now between the 14 and the 21, is there a sign change there? No, they're both negative. You're good. Okay. What this is telling me, hear me out, is this. Being that there's a 1, now hear me out. Being that there's a 1, anytime there's an even number, that's going to be different. I'll show you here shortly. Okay? But notice, with a 1, that means I'm guaranteed 1 positive real number. Guaranteed. I don't know what it is. I know that kind of sucks. You're like, well, how'd that help? Well, it does. Okay, it'll help us out a lot because let's say I'm doing my test, right? And all of a sudden I test out that +4, right? How many other positive numbers am I going to have? None. I can't have any more. This rule says I only get one, and then after that, I'm done. Okay, so then you know how our list had pluses and minuses? You've just now eliminated every other plus symbol. You don't have to worry about them anymore. You can now just focus on the negatives. Okay, I know you're sitting there going, well, does that matter? Yeah. If I got a list of 32 and now I just knocked it down because I found one positive, now I've just knocked it down to 15. Bro. Okay. Hint, hint, by the way, not many math teachers go very far into the list. Okay, so don't freak out too much. Okay. But now you gotta do, but now we've only tested for the positive. Now we gotta try the negatives. Now here's what you do. You're gonna take f of -x. Okay, you gotta change everything. So notice, can I help you out with a little bit of a trick here? How do I say this correctly? If I have -x cubed, am I gonna get a negative when it's all said and done? Why? Why wouldn't I?
This symbol.
Negative times a negative creates a
Other.
times a negative.
Negative.
You're gonna get a negative, right? Because it's an odd number. Does that kind of help you out a little bit? But if I had a square there, like if I did -x squared, what's gonna happen to that -x? It's gonna become a what? Positive, and that basically turns to a 1, so nothing changes. So really, if you think about it, whenever you're plugging in this number, this -x, all you need to do, change the sign of every single odd power. Let me show you. I'll do the whole math so you see it, but I'm just trying to save you time. Okay? Notice what we have here is 2 times -x cubed plus 3 times -x squared minus 14 times -x minus 21. Well, hey, we literally just said -x cubed will become a negative, right? That negative is going to stick around. So now this is going to become -2x cubed. But then nothing's going to happen to that 3x squared because -x squared just turns into x. Okay, so that just turns into plus 3x squared. What's going to happen to the 14? Is it going to go positive or going to stay negative? Yeah, it's going to go positive. And then we got minus 21. There you go. Now do it again. Now we're testing signs again. Notice on this first part here, hey, sign change, isn't it? And then no sign change between 3x and 14. But then what happens at the very end? I got another sign change. Oh. You want to know if you did it right? First off, notice, hear me out. Hear my words. I have the possibility. I just ended up with an even number. There's a possibility. I could have up to, no more than, up to 2 negative roots. What could I also have? Now think about it. Hear me out carefully. Remember whenever you were solving the last one? What did we end up with? We got that x minus 4, but what else did we get? 2 complex numbers. This doesn't find complex numbers. You can't find complexes using this. In the factoring process, they will come out. But you're not going to find them doing this. So could I also possibly have 2 complex numbers in there and just don't know about it? Yeah, so I could also have 0 negative numbers. Okay, you always subtract by 2. Anytime you get it even. So I could also have 0. Because what else would it be? If it wasn't two negative numbers, what would they be? Complex, right? Because you have those conjugate pairs that could be hiding in there. You just don't know it yet. That can help you a little bit. Same thing with the positive. Okay, if there was like a 2 up there at the positive, I could have at most 2, or I could have 0. But let me say if you did the math right. My maximum number of negatives is how many? 2. I'm also guaranteed how many positive? What's 2 plus 1?
3.
What's the degree of this polynomial?
3.
I'm guaranteed at least 3 answers. I have to have zeros. I have to have 3 zeros. They don't have to be real, but I could solve this and get 3 zeros. 1 real, 2 complex, or one positive real and 2 negatives. But that's what Descartes' rule tells us. It says, hey, this is what you could possibly have. See if it helps out a little bit. Because think about it. What helps me on this one is knowing, man, if I find 1 positive, well, then what? I don't got to worry about any other positives anymore. Does that help y'all? Okay. Another trick that you can use. I'm only going to show it to you once. It's actually because of the numbers we'll be using in this class is a lot simpler. Okay, I don't use it very often. So if you want to write this down, you can. I use Descartes' rule all the time. All the time. Okay. But this other one is called bounds of real zeros. Okay. All it's doing is this. I get a big list of numbers. Okay. What if I could take those numbers and say this? Man, that's large. What if I could say, hey, I can guarantee there is no real zero, positive real zero above this number, and it doesn't go down below this number. I've at least bounded it to where maybe instead of having this huge list, I've only got to worry about this list. I've kind of just shrank it. That kind of help out a little bit. All I'm going to do is after I get my whole list of numbers, okay, now this one, let's find out the zeros just so we have the practice of it real quickly. Remember, you have a P and you have a Q. And remember, trust me, it's going to make your life easier. Write this as P and Q, because remember what you're seeing is actually this, right? What are all my factors of 21? Well, how about 1, 3, 7, and 21? We good with that? What are all my factors of Q? Pretty straightforward, isn't it? How about 1 and 2? But now I've got to start saying this. I need to list them all. These are all my possible zeros. Well, I can go here plus or minus. Good thing is, now, here's one of the hardest parts. How many numbers do I have on top? How many numbers do I have on the bottom?
2.
What's 4 times 2? That's how many numbers should be in your list when you're all done. So if you do your math and you don't have 8, you're missing one somewhere. Double check it. Okay. Notice we can't we just rewrite the 1, 3, 7, and 21 automatically, because when you divide all those by 1, you're just going to get those numbers again, right? So then I come here 1, 3, 7, and 21. But then, now here is the rub. Now you've got to start adding in your other ones, okay? So notice 1 divided by 1 is just 1, or sorry. Now you got to come here and go, okay, well, how about 1 divided by 2? Well, isn't that just going to be 1/2? And then I get 3/2, 7/2, and 21/2. And so there is your listing of all your possible zeros, which gives us 1, 3, 7, 21, gives us 8. So our total list is actually going to consist of how many numbers actually?
16.
16, because we got pluses and minuses. That's a pretty big number, and man, it's got some fractions in there. Well, let's see if we can bound it. Let's make it a little smaller. All you do is you pick a number. Okay, for this one, let's pick 3. Okay, I picked 3. And I want to say 3 is my upper bound. I'm going to do some synthetic division. Now, hear me out. I don't care if it creates a 0. Now, if you're lucky, this happened to me actually when I do this. I picked one, I actually picked a 0, and I was like, dang, can't use that now. So I'd pick another number. If you get a 0, you're like, oh, lucky day, I found a 0, and then you just go to step 2. Okay, and how do you know if you got a 0? You're going to end up with a what at the end? A 0, very good. Okay, so I come in here, I'm looking for my upper bound. I'm going to do my synthetic division. Let me go up a little bit so I can see that. And I just write down my 2, my 3, my negative 14, and then my negative 21. Give myself my freebie and then just start doing the math. This is going to give me a 6, a 9, an 18, and a 4. 4 times 3 is what? 12. It's up somewhere here. See, 9, 18. Up at 9, 18. That's a 27. 9, 18, 27. It was 12. What's 14? Negative 14 plus 27. 13 exactly. And I do 13 times 3. Huh?
39.
39. And then, of course, what is that's going to end up right there at the end? You end up with 18. I don't care that I end up with 18. You know what I end up with? All positive numbers. Okay? That tells me 3 is an upper bound. There you go. Why does that matter? Because anything above 3, I won't use anymore. Well, what does that mean? Well, the positive version of 7 over 2 is gone. The positive version of that guy's gone. I'm also not going to use the positive version of 7. I'm also not going to use the positive 21 there. Now, I've still got the negatives to deal with, right? So in all of these, I would still have a negative 7 to deal with, a negative 21, a negative 7 over 2, and a negative 21 over 2, but nowhere else, right? I've now found an upper bound. Well, let's find a lower bound now. Okay, and you can do the same thing. Now, you're not looking for all negatives. Okay. Let's make it a little bit meaner. That negative 21 over 2, does anybody tell me what that number actually is? First off, it will be a lower bound, I can guarantee you. It's the little, and you could have gone negative 21 if you want to, or negative 7, but I did negative 21 over 2 because I wanted to see how you see it. I wanted you to see how to do synthetic division with a fraction. Okay. So notice I come in here and I'm going to write down negative 21 over 2. And then you always write down your original. And so I've got the 2, the 3, the negative 14, the negative 21. Obviously, you got your freebie here. And there you go. Well, 2 times negative 21, remember the 2's are going to cancel out, or sorry, reduce out, and that's just going to leave me with the negative 21, right? Do the math of that, you're going to get negative 18. I'm going to do this kind of quick for you, just kind of help you out. And how you can do this is do negative 18 times negative 21, and then divide that number by 2, and you're going to get 189. Do the math to that, you're going to get 175, which I would take that 175 in my calculator, multiply it to the negative 21, and then divide that number by 2, and then you're going to get a very ugly number of negative 1837 and 1/2, or 0.5 on your calculator. And notice here I get negative 1858 and or 0.5 or 1/2. We don't worry about the ugliness of the numbers. What I want you to see here is guess what just happened? Positive, negative, positive, negative. They alternated. Okay, that means negative 21. Well, that's the lowest that thing can ever go. Okay, it will not go past, so that guy is also now gone. Now, I picked a very large number, okay? But think about it. Negative 21, that's going to end up being what? 2 will go into that, what? 10 times. So could we also say that probably negative 21 is also going to be off our list as well? Yeah, because it can't be any lower than that, right? So think about it. This ends up being the lower bound is negative 10 and a half. It can't be anything smaller than that. So I've also gotten rid of what? The negative 21. So now all I have left here is plus or minus 1, plus or minus 3, plus or minus 1/2, and plus or minus 3 over 2. And then don't forget that negative 7 over 2. Now, could I have brought that guy in a little bit, maybe? Does that make sense? But notice I've taken a large list and kind of done this and went, let's shrink it. Now, I'm going to be honest. That's pretty labor intensive, isn't it? It works great when you have a large amount of numbers. I mean, we're talking 20, 30. Think about it. It wouldn't have been very hard to create an extra amount of numbers had that leading coefficient been a 4. There you go. That's adding on. Now you got 1, 2, and 4. Now you've got a whole other set of fractions you're going to have there at the very end. Does that kind of make sense? How your list can grow really, really quick. Okay. So maybe if you have one of those, be a good idea to check. Are you good with Descartes' rule? Are you good with everything else? Let's do an example. And then we're going to jump right back in, okay? Let's do an example of one right here. Intermediate value theorem, okay? And we're going to do an example, hopefully. We might not get to an example today. We'll get to them tomorrow. Intermediate value theorem says this, okay? Assume that f of x is a polynomial with real coefficients. Real coefficient means you can't have complexes in there, okay? It just means they got to all be real numbers. And a and b are real numbers where a is less than b. If f of a and f of b differ in sign, then there is at least one point c between these 2 points that equals 0. Okay? Let me show you the picture. Look at the picture here. Here's f of a. Look at f of a. It has dropped below here, right? Here I have f of b. What it's saying is this, is when you give me f of a, let's say whatever function they give you, right here in this function, you plug in that a value right there, that x, okay? You're going to get a positive or negative number. Well, notice on this one, if I calculated it all out, we can see that a is what? X is a, right? When I go down, what number am I getting? A negative value, right? So we know this guy is negative. When I calculate b, is b, f of b going to be positive or negative? Yeah. Notice you had a sign change from here to here. That says you have a possible 0 in there. Hence the word, once again, I hate to say it, you're in the fuzzy math world now. Possible 0. It could be a complex number. Okay, but I'm just saying right now, it's a good idea. It lets you know, hey, it's there somewhere. Isn't that kind of what we just did a little bit? That's what intermediate value stands saying, hey, if you go from here to here, I'm saying there's something happening in here. Okay. This one you're going to do a lot of math of in this section. It is something that comes up a lot later on in math. Because you kind of want to know what the behaviors of things are. Because we're used to looking at graphs. But let's be honest, a lot of times you're just given equations, right? And you still want to know the behavior of things happening between certain lines. Are you good so far? Very quickly, let me do this one right here. And then we will call it a day. Does the intermediate value theorem guarantee that the following function has a real zero between 2 and 3? Well, let's find out. All you would do, remember, you got to go A and then B. A is less than B, okay? So you got to go smaller number first and then larger number. So notice this is my A, this is my B. So f of A would literally be 6 times 2 to the 4th minus 150 times 2 to the 3rd plus 438 times 2 to the power 2 plus 870 times 2 plus 600. You can do all that in your calculator. I'll do it for you real quickly to save time. And you get 2988. Isn't that all we're doing right there? What number am I plugging in next? 3. Yeah. You're gonna do the same thing again. What am I looking for? What should happen?
Zero.
We're looking for a sign change. Intermediate value, we're looking for a sign change. We're not looking for a zero right now. We're just looking to say, it's saying, hey, between 2 and 3, when f is f of 2 and f of 3, are you guaranteed a zero in there? Well, let's see. The only way I'm going to know is if there is a sign change. So on this one, I would do 6 to the power of 4 minus 150 times 3 cubed plus 438, 3 squared plus 870 times 3 plus 600. That's going to equal 3588. So tell me, am I guaranteed a zero in there? No, I'm not guaranteed what type of zero. Real zero. Does that mean I couldn't have a complex in there? You could, okay, but that's not what we're testing for. No, there was no sign change. These were both ended up being positive numbers. So no, f and a and f and b do not differ in sign. And so a zero is not guaranteed. Once again, complex numbers are our own world, and you got to figure that out in other methods. So this right here, no, it's not guaranteed. And now, after that, this is going to be to be continued. Okay, hear me out. We're going to finish up 15.3, 15. Tomorrow we'll finish up 15.3. We'll probably get done with 15.4, and then we'll finish up 15.5. I was hoping to get into 6 this week, but to be honest, well, with the missing day, but also I want to make sure you understand that. Play with it. Okay. Guy that's annoying. Do you want a hint on how to do it real quick? To make, okay, if you want to make it easy on yourselves, and I'm not telling you to cheat, because I will fail you on your final. So gladly, I give out free zeros. Okay, hear me out. Go in and put this in Desmos. Or even if you have to, put it into a math program, okay, that gives you a zero. Like, sure, maybe it factors the whole thing out for you. Fine, it helps you find a zero. If you you can kind of understand the concept of going, I understand what you're saying. I get this big list of numbers and I've got to find a zero, and then I start doing synthetic division. What you're doing in 5.3 is saying this: if I gave you something to the 5th power, and then I find a zero, 1 0, I run it through, right? Well, now I'm taking that whole thing and taking it down to the 4th power. Well, then you look at it and go, is this something I could factor right now? Well, to the 4th power, you might still have 5 terms in there because you got that constant hanging out, right? So then you may have to go back in there and test it again. Now, hear me out. If one, let's say one was your number, you might be able to use one again. Think about it. When you factor, didn't you get sometimes x plus 1, x plus 1? The double root. It could work again, so double check it. Now, once something doesn't work, it's off the list for good. Okay? Does that kind of help you out a little bit? So then you take that x to the fourth. You've already figured out one of the roots, or one of the zeros. Now you've got it down to the x to the fourth. You do the synthetic division again. That means you got to go back through your list again. Now it takes it down to the x to the power of 3. And around a cubic function, you're going to be down to 4 terms. You're grouping at that point. Now you've got something that you have tools to factor, quadratic formula, grouping, whatever. You're just trying to use this finding zeros to get it down to where somewhere is where you can factor it using other methods. You don't have to keep using this method. But this says, hey, if I give you something, a 12th degree polynomial, you're going to hate life. But could you factor it? Yeah. You're going to go, okay, man, here we go. We're going to start. We found it was 0. Now we broke it down to 11. We're going to do it again. We broke it down to 10. We broke it down. We broke it down to 9. And you just keep going through. Boom, 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 boom. If I had something like that, would I probably use, I will always use Descartes' rules, but would I probably use the bounding rule? Yeah. Try to narrow down my numbers a little bit. It helps sometimes. It helps sometimes. It doesn't. It really kind of depends on what your last number is and your first number is. If you've got a lot of factors, then that's what sucks. If you end up with like a 1 and a 2, you're gonna be like, dude, I got this. This is gonna be easy. Okay? Because that's the hard part, is that list of numbers. Okay? We're gonna do some examples, but none of your examples, I believe, I don't even think any of them go to the 5th power. I think they go to the 4th. So pretty much once you find one, dude, we're in the thirds. We can factor powers of 3. Because think you're gonna have 3, 2, 1, and then a constant. Well, that's only 4 terms. That means I can group. So you're really only doing it once. Okay. Now in your notes, whenever I show you in the next class, I wrote one down that's a power of 5. So I had to do it twice. Now, mind you, I didn't show all my I cheated. Save time for me at home, but it still is the same. So if you go on there and you start saying, hey, I found a 0 using Symbolab, Quizlet, whatever, do it and then go in and do the math and see what you can do. Get used to the process so that way when you do it on your phone, you're like, I got this. Okay. If somebody will remind me tomorrow before class, I'll walk back over to my office. I won't do it today, but I'll come bring you the note cards. Because remember, for your final, you're allowed note cards, a 3x5 note card. Okay. All right, guys. I'll see you all tomorrow.